sometimes in order to answer a question, you should understand to which variables we have to apply the quantifiers, and then how to distribute the quantifiers over a compound statement. So what I mean to say is, sometimes question will be given like this: for all x plus y plus z equal to 10, something like this. Now if you observe this here, if you observe this statement, you might think that for all x is applied to x, y and z as well, but since you can see for all x and x here, it is as good as applying for all quantifier only to x, which means this statement is equivalent to a statement like this: for all x like this plus y plus z equal to 10, right? So we have applied the quantifier only to x. So sometimes in this case, this is also called as x is called as the bounded variable, because x is bounded by the quantifier for all, and y and z are called as the free variables. The reason why they are called as the free variables is they don't have any bounds, right? But this is bounded. Understood that? And also sometimes what happens is you have to understand, like I'll just give you an example. So this if you can understand this, you can answer many questions easily, because most often what happens is you have to split it. You have to distribute the quantifier to the parts where it is required, and you have to separate it out. Now I have separated this out. Got it? Now what I mean to say is, let us say we have a statement like this. So here, you have to understand that these are some other quantifiers, logical connectives. Even though I have written plus, you try to substitute it with some other quantifiers like r and. Now let us say we have something like this: for all x p of x, or there exists x p of x, and then for all x q of x. Now in this case, this x here is bounded to the quantifier there exists, and this x here is bounded to the quantifier for all, right? Therefore these two have to be separately implemented. So, or in other way, if you want to think about it, we can say that the scope of this quantifier is only till this part. You should not take this there exists to this part. Similarly, the scope of this one is only limited to this, right? So even though the same variable is used, actual meaning is they are both have to be treated as separate variables. So writing like this or writing like this, both are same, right? See this: for all there exists x p of x, or there exists y q of y. These two are same. In fact, this one will be easier for you to understand that these two are different. But in most of the questions, you might see that same variable will be used, but with a different meaning. Here the meaning of x is different, and here the meaning of x is different, but it is just used as a variable. Got it? So if you are getting confused anywhere, you can expand it this way. And also sometimes if you distribute the quantifiers, it will be easy to understand. So I'll just tell you an example. Let us say we have a quantifier like this: for all x is there and the propositional function p of x is there. Let us say the domain of disclosure is x1, x2, x3, right? Now I told you that one way of understanding this particular thing is p of x1 and p of x2 and p of x3, which means the truth value of this statement depends on the truth value of this compound statement. These two are actually equivalent. What does it mean? whenever for every value of the domain, if the predicate function is true, then only this one is going to be true. I think you know that, isn't it? Now if I have something like this, for all x, let me write it here, for all x, p of x and q of x, let us say the domain is x1, x2, x3, right? Now what is the meaning of this one? Let's take domain is x1 and x2, let's keep it small. The meaning of this one is p of x1 and q of x1 and p of x2 and q of x2, isn't it? Which means for value x1 these two have to be true, in case if it has to be true, and for value x2 these two have to be true. See, simple. What did I do? I have taken all the elements in the domain and I have substituted there and expanded it. Now even if you take this statement for all x p of x and for all x q of x, both will be same, right? So if you try to evaluate it over the same domain, then what do you get? P of x1 for the same domain and p of x2, isn't it? And we already have an AND. Now what about this q of x1 and q of x2, right? So therefore if you observe this, these two are same. So what do you understand from this? For all, quantifier can be distributed over conjunction, right? Now if you try to distribute for all over disjunction, it will be false, isn't it? Why do you think that it will be false? See this, the meaning of for all x, p of x or q of x over the domain x1, x2 is going to be p of x1 or q of x1 and, right, p of x2 or q of x2. Now if you try to distribute over this for all x p of x or for all x q of x, then here you are going to get p of x1 and p of x2 or q of x1 and q of x2, right? So now these two are actually different, isn't it? So this is different, this will have a different meaning and this will have a different meaning. Therefore whenever you see for all given, you can distribute over conjunction only, you cannot distinguish, you cannot distribute over disjunction. Similarly, if you have a there exists quantifier, you can use the same method of proof and you can say that this there exists is distributive over disjunction, which means if I have something like this, if I have something like there exists x p of x or q of x, then I can write it as there exists x p of x or there exists x q of x. The reason is when you have this there exists, it has to be expanded using this disjunction only, and since you are expanding it anyway using disjunction, if there is already a disjunction present, then we can distribute over it. You'll understand it logically if you can write this there exists also using this. Since it is trivial, see, once I done this, I think that one is easy to get it. So what you can do is you can do the same kind of proof and you can understand that there exists is distributive over disjunction and for all is distributive over conjunction, and the reverse is not true, which means for all is not distributive over disjunction, and similarly there exists cannot be distributive over conjunction. Okay, this is very important point. So in most of the cases when you just distribute the quantifiers, you will get the answer. When you know where to apply the quantifier, you will get the answer. And sometimes when you know that the two variables naming doesn't make the difference, you will get the answer in some of the questions. In this topic, most of the questions will be like that. Just rearrange the terms and expand them, and you are going to get it. You know what? Here we have discussed about what happens for all and there exists on conjunction and disjunction, but then we didn't discuss about what happens for implication, right? But you know that implication can be written as, for example, if you have P implies Q, we know that this can be written as negation P or Q. Therefore you can make it into this, and then we can expand it, right? So we shall see how quantifiers are going to interact with the other logical connectives when we try to expand them over them. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries, for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.